Chapter 1 homework for the college physics really starts numerically with 16 on page 27. There's several level 1 problems. You should do 2 of them. So let's do the first 2. Number 16 says, show that the equation x equals xo plus at vt is dimensionally correct when x is measured in meters, or a measurement of length, and v is measurement of velocity. V is meters per second. So let's plug into the equation, and we'll say that meters is equal to meters plus meters per second times time, which would be seconds. They will cancel out as meters dimensionally equal to meters. And so meters is equal to meters plus meters. And so that's dimensionally correct. So the answer to the first one is, in fact, yes, and that's the proof. Question 17. Now this is kind of tricky because it gives you lots of options. If x is distance, so that would be meters, and be referring to distance. V is velocity, and there's different kinds of velocity, original and velocity, which is meters per second. Dimensionally, both of those are the same. A is acceleration, and it doesn't really tell you. You'd have to go look up in the chapter acceleration, and that's meters per second squared, or meters per second times seconds. And finally it tells you t is time. Which of the following equations is dimensionally correct? And the first one is distance equals VOT plus AT cubed. So that would be distance. Meters is equal to meters per second times seconds. Okay, so that would be meters. Plus acceleration is meters per second squared times t cubed, which would be seconds cubed. And so they wouldn't cancel out, and so that's not dimensionally correct. So the first answer is no. The second equation, B, is velocity squared equals VO squared plus 2AT. So let's see, that would be meters squared per second squared is equal to meters squared per second squared plus 2 times A, which is meters per second squared, times seconds, time. So meters squared per second squared is equal to meters squared per second squared plus meters per second. That would also not be true dimensionally. The third one, x is equal to x is equal to, let's go ahead and delete that. Okay. X is equal to AT plus VT squared. So meters is equal to meters per second squared times seconds plus velocity, which is meters per second, times time squared, which would be seconds squared. And so no, it doesn't. That's not going to be the correct answer. And finally, it's V final. V squared is equal to VO squared plus 2AX. So the dimensions would be meters squared per second squared is equal to meters squared per second squared plus 2 times acceleration, which is meters per second squared times meters, and that would make it meters squared per second squared. The correct choice for number 17 would be D. There's the proof. Okay, we're asked to find if the equation area is equal to 4 pi r squared is dimensionally correct. Well, let's just substitute in units. What are units of area? Well, area is one dimension times another dimension, so it would be meters squared. 4 is dimensionless, pi is dimensionless, and so r would be the radius of a sphere, which could easily be measured. We're going to square that, and so it would be meters squared. So in fact, the answer to this would be yes. It is dimensionally correct.